and she was doing inequalities.
Mm-hmm.
And I remembered how to graph them, and I don't know how I remembered how to graph them.
No, so you had a good math teacher last year.
Yeah.
So,
And I was like, that's going to be open circle. And she's like, how? And I was like, I just remember from my notes. And she was
Good.
like, how do you do that? And I was like, don't ask me how I do it. I just remember.
Good for you. Proud of you. Okay.
Never going to use it in my life.
Okay, we're going to graph the sine, cosine, and tangent graphs. We're also going to eventually graph the cotangent, secant, and cosecant graphs. Okay, so people at home, just you guys, if you've already done this, you want to, where it says section 4-6, you just cross that out. This is when we were using a different textbook. This is just put down, what section are we on? 2-4 now, is it? Yeah, we just did 2-3 homework quiz. So you want to just make it section 2-4 instead of 4-6. Okay, and then the upper right-hand corner, they give you 4 different fractions. And if you guys could, it says radical 3 over 2, radical 2 over 2. You might want to jot these down, radical 3 over 3, and radical 3. Somebody want to type in on your calculator, on your phones or whatever, you can use your phones on this. Radical 3 over 2, just give me a ballpark figure. The square root of 3, whatever that is, divide by 2. And the square root of 2 divided by 2, and so forth. So like a couple decimal places. Yeah, it probably does work better if it's turned on. Nobody else has a phone? Come on, you guys all got phones, don't you?
just thought that.
My calculator is being done.
Somebody want to punch it in on the...
Put in just the
Yeah.
normal graph.
You getting that?
I don't know how to work.
Square root things?
The buttons are weird.
All right, I'll tell you what. Until you guys can figure that out, I'll just grab a calculator back here. We'll start doing this. Okay. So we have radical 3 over 2.
0.86.
0.866. It's about 0.87.
Yeah.
Okay. Radical, I'll do radical 3. Radical 3 is 1.73. If I divide that by 3, you get 0.558. About 0.58. Did you get radical 2 divided by 2?
It was 0.70.
0.70?
Yeah.
Okay, so we'll go ahead and put those in there, okay? All right, now again, I just want to make sure you understand. The way we're going to be doing these today is not the way you're normally going to be doing them, okay? We're going to plot a whole bunch of points in order to see what these graphs look like, and then we're going to show you the short way of doing it, okay? So if you don't have your unit circles out, you want to get your unit circles out, okay? So we have... We also have I'm not going to put all these in here because it's too crammed together as it is. Okay, so I'll just watch for a second right here, okay, and then start filling things in. So if I gave you, we're having y equals the sine of theta. Okay, so instead of having our x-axis and our y-axis, this is our theta axis and this is our y-axis. I mean, we could use x, but it's just typically theta represents angles, and that's what we're dealing with here, are angles. So if we start on a unit circle at 0 degrees, at 0, or actually it should be 0 radians, it doesn't matter, 0 radians. What is the sine at 0 radians? If I asked you at 0, what is the sine at 0?
0.
0. So, and then, so I'm going to plot the point 0, 0. Go ahead and plot that point. Okay. Now, we're going to work our way around the unit circle. So look at pi over 6. We're right here. We're going right across here. This is pi over 6. I just didn't label it pi over 6 because I don't have enough room, okay? At pi over 6, what is the sine at pi over 6? A half. Now, a half is 0.5. So at pi over 6, go up to 0.5. Go up to a half. 0.5. and work your way around the unit circle. So what we did here is we're going like this. Around the unit circle, we did 0, we did 30, now we're at 45 degrees, or pi over 4. What is a sine at pi over 4? And radical 2 over 2 is approximately what? How do you know that? Because it says so right there. So at pi over 4, go up to about there. Okay? Hopefully yours looks better than mine because I tried to make yours spaced correctly, where mine's just, I threw it up here shorthand, freehand, okay? So at pi over 6, we said it was 0.5. At pi over 4, it was 0.70. And then at pi over 3, at pi over 3, what is it? Radical 3 over 2. What's radical 3 divided by 2? 0.87. So we're just making a t-chart and doing this. So at pi over 6, or pi over 3, we're up here at 0.87. Okay? And then at pi over 2
It's 1.
is 1. How are you getting these answers? They're looking at the unit circle, okay? All right. Now, let's keep on going. After pi over 2, we're at, let's see, 120, 2 pi over 3. Radical 3 over 2, which is 0.87. So, at this one, it should be right across from that. It's the same distance up as it was at pi over 3. How about at 3 pi over 4? It's what?
It's mirror what we just put.
Wasn't it radical 2 over 2? Okay, which is 0.70, which 3 pi over 4 should be right across from this dot. So where do you think it's going to be at 5 pi over 6 without looking through the circle?
Right across.
Right across from it, so it's going to be at a half. And where's it going to be at pi?
At pi.
At pi, it's going to be what? Well, 0. So we got kind of like this hill right here. Okay? Now, looking at your unit circle, does it make sense that sine was always positive when you looked at y? One word. Up. They're all up. Now, as we continue around the unit circle, we've gone this far. What do we know about the sine values here?
Negative.
They're all negative. So as I continue this, where do you think we're going to find the sine values? Above it or below the x-axis or the theta axis? They're going to be down here, okay? So, here's what we got. 0.5, negative 0.5, and negative 1. Okay, so we look at our unit circle at, what is that, 7 pi over 6? Is that negative half? Is that what our sign is?
Yeah.
Okay, so we go down here to negative half. At 5 pi over 4, what is it, negative radical 2 over 2?
Yeah.
Which is negative 0.7. So down about here. And at, what's after 5 pi over 4? Can't do these in my head.
4 pi over 3.
Okay, 4 pi over 3, and what is that? Radical 3 over 2? Negative radical 3 over 2?
Mm-hmm.
Which is negative 0.87. So right about here. And at 3 pi over 2, what is it, negative 1?
Mm-hmm.
Okay. Where are we going to find these other 3 dots? Straight across from these. Okay? So after 3 pi over 2, what is that, 4 pi over 3? Is that what's next? No, that's not it.
5 pi over
5 pi over what? 3?
3.
5 pi over 3, we're going to be at negative radical 3 over 2, which is negative 0.877, roughly. At 7 pi over 4, it's going to be right across from this. At 11 pi over 6, it's going to be at negative half. And at 2 pi, it's going to be back up there to 0. Now, I didn't mean to rush through this. Are we okay with what I did right there? Did you see where, I don't want to lose anybody on this. And if you're sitting there going, God, we're going to have to do these for all of our graphs. No, this is not the way we're normally going to have to do these, okay? Now, hopefully yours looks better than mine. If you're sitting there going, oh, I can connect these like a, no. This is what's called a sine wave. Okay, waves have curvature. What it should look like, mine doesn't look half bad, I'm doing worse. It goes like this, ooh, try to connect the dots like this, this. Okay, hopefully yours looks better. Mine, I drew this down too far. So go ahead and connect the dots like that. That's a sine wave. Now let's be honest here. While you guys are connecting the dots right there, don't think hard on this. Can we continue on? On this worksheet, can we continue on to the right?
Yes.
on this worksheet? No, why?
Pages.
Page ends. You can't go any farther than that, okay? But what would happen if we got to 2 pi? It'd restart. It'd look like what? It looked like the same thing, okay? 7 days from now is a Monday. 7 days after that's a Monday, okay? How about 7 days before today? It was Monday. So we can't go to the right, but we can go to the left. So here's what we're going to do. Okay? Here's what we're going to do. And what's it going to look like over here? It's just going to be this thing. Now be careful. Some students think it's going to be reflected over there. No, it's not. It's not going to be reflected. It's going to be picked up and put right. Because if you reflected it, it's going to be a mirror image. It's not going to be a mirror image, okay? So here's what we're going to do. We go all the way to negative 2 pi. And here's negative pi. We're not going to plot all those points. Okay, we're not going to do that, okay? We don't need to. We just did it so you could see what it is that the thing looks like, okay? When you look at this, this is one cycle of a sine graph, one cycle. How many, they're what are called critical points. How many critical points do you think? I mean, we plotted 1, 2, 3, 4, 5, 6, 7, 8, like 15, 16 points or something like that. We didn't need to plot all those, I don't think. How many points do you think we needed to plot? I would say 5. What's the first one? 0, 0? I think that's important. Why is that important? That's where you start. The starting point's important. How about the end? That's important. The highest point, the lowest point, and right in the middle. You need 5 points, okay? You need 5 points in order to do this, okay? So, again, we're going to take this and move it back here. So, no, look, you don't get to look at the circle right now. Where are we going to be at negative 2 pi, you think? Any ideas? At 0. Where are we going to be at negative pi? Also 0. Where are we going to be at 0? 0 as well. How about negative 3 pi over 2? Where's that going to be? Up at 1. And where's negative pi over 2 going to be? Down at negative 1. Those are our 5 points. That's 2 cycles of a sine graph. So, when we're doing our assignments over the next week or so, we're only going to do one cycle. Only one, okay? And it's always going to be this one, the positive one, okay? But you could do, you could do more to the left, more to the right, more to the left, but we're only going to do one of them, the first one to the right. So, here's what I'm getting at. If I ask you to graph y equals sine theta, okay? Here's what I want you to be able to do. Not do all this stuff. Here's what you would do. You would go from 1 to negative 1, 2 pi, pi over 2, 3 pi over 2. Here's the way I say it. A sine wave starts right in the middle. This is the high point, that's the low point. These are the midpoints, these are the middle, okay? High, low, right in the middle, okay? Sine starts at the midpoint, it ends at the midpoint, and halfway through, we're on 0. At pi over 2, it's a high point. At 3 pi over 2, it's a low point. There is a sine graph. That's what I want you to be able to do, okay? And again, it'd been a whole lot easier for me to just say, here it is, do it. Just like the unit circle, it'd been easier for me to say, here's the unit circle, memorize it, okay? So that's what a sine graph looks like. Now, we're going to do the shortcut for a cosine graph, okay? We're only going to hit the main points that we really need to, okay? So, let's do this. Move this so that people at home can see it. So we have y equals cosine theta. Now I will tell you this. We're going to jump ahead here a little bit. The tangent graph's going to look a little different than the sine and the cosine graphs. Any idea why? If you look at the unit circle, that gives you a little clue. Any idea why the tangent graph's going to look a little weird?
Because of the undefined.
Because of the undefineds. Okay. It's going to make it look. I mean, you might wonder, how do you graph undefined? Well, we'll talk about it in a few minutes. Okay. So a cosine graph. Okay. Let's do the same thing here, but we're only going to hit the main points, okay? So 2 pi, pi over 2, 3 pi over 2. And here at 1, here's at negative 1, okay? At 0 radians, what is the cosine? You can use your unit circle now. What's the cosine at 0 radians? What's our cosine at 0? 1. So do we start right here? We start at here. Okay. What's the cosine at pi over 2? What's that? No, pi over 2. It's 0. We're not doing all the points this time. We're gonna hit the main ones. What's the cosine at pi? -1. What's the cosine of 3 pi over 2?
Probably 0.
Not probably 0, definitely 0. And how about the cosine of 2 pi?
One.
1. Now, before you connect them, okay, you might go, oh, that's a V. No, it's not, okay? If we were to fill in more points, you would see it's still curvature to it. Students have a hard time with this, okay? Here's what you do, okay? How it should look. It really should look like this. We're going to do it in 1, 2, 3, 4 pieces, okay? Here's what you want to do. You want to connect these with an arc, but it should go like this, okay? And then we're going to connect it here, but it's going to go the opposite way. Instead of arcing this way, we're going to arc that way. And then we're going to connect up here just like we did this one. And again, it doesn't go like this, it goes like that. So, does a cosine wave start at the midpoint? No, it starts where? Cosine starts at the top point. It starts at the high point, okay? Now, if we went further to the right, it would repeat itself. It would repeat itself over and over and over and over again, okay? We're going to go 1 to the left. So here at -2 pi, -pi, -3 pi over 2, -pi over 2. So just take this, pick it up, and stick it over there. So where are we going to be at -2 pi? No, not 0. Up at 1.
Wait, why'd you go so?
What's that?
Nothing.
You good?
Uh-huh.
Okay. Where are we going to be at -3 pi over 2? 0. How about -pi? -1 and -pi over 2 is 0. And it looks like that. So that's 2 cycles of a cosine graph. 2 cycles. Now, when we do our assignments, I don't want 2 cycles. I just want 1 cycle. So, here's what I want you to be able to do on a cosine graph. So if I ask you to graph a cosine graph, what you need to understand is a sine graph starts right in the middle. Cosine graph starts at the high point. So it's going to start way up here. You need to plot this point, this point, this point, this point, this point. This is going to look a little funky because I didn't evenly space these out. That's cosine graph. Any question on that? Okay. Trying to show you tangent ones next or not? No. I think we're going to do, we'll do tangents probably tomorrow. What we're going to do today, though, is this. We're also going to graph, this right here is y equals sine of theta. This right here is y equals cosine of theta. What I would like to do, this is going to be really tough because there's not a lot of room when I made this up, okay? I apologize for that. When I made this worksheet up, I should have put them on both front and back of the paper so you had more room. We're also going to plot the cosecant graph, and we're also going to do the secant graph on that one. Why do you think I'm going to put cosecant and sine together and cosine and secant together? They're reciprocals, okay? Now, we got to talk about some number theory, though, before we actually start graphing this, okay? If I gave you a number, okay, like for example, if I gave you 1, 4, 8, 10, 20, 50, 80, okay? I give you those numbers. The numbers are getting bigger. 1, then 4, then 8, then 10. Numbers are obviously getting bigger all the way up to 80, okay? I just throw some numbers up there. Don't worry about where I got those numbers, okay? Now, if I ask you for the reciprocals, the reciprocal of 1 is still 1. Reciprocal of 4 is 1 over 4, 1 over 8, 1 over 10, 1 over 20, 1 out of 50, 1 out of 80. So, what I want you to understand is this. I'm going to say this 2 different ways, okay? As numbers get bigger, the reciprocals get smaller. Okay? I'm going to say that a different way though, okay? As numbers get farther from 0, okay? Now that's another way of saying getting big. If it was just positives, okay? As numbers get farther from 0, their reciprocals get what? Closer to 0, okay? And we got to be careful because if it was negatives, everything's backwards, okay? If I gave you these right here, say these were all negatives, okay? Here the numbers are getting what? smaller, okay? So here, they are actually getting bigger, okay? But they're getting also closer to 0. I want you to think of it this way. As a number gets farther from 0, its reciprocal gets closer to 0, and vice versa, okay? As a number gets closer to 0, its reciprocal gets farther. They just do the opposite from each other, okay? So, let's look here at the sign graph first, okay? And I will just watch this for a second, okay? I will just watch. All right, so we need to find reciprocals, okay? So we're going to deal with these points right here, these 5 points. Right here, well, we already had, let's do this. Theta and sine of theta. We had at 0, pi over 2, pi, 3 pi over 2, and 2 pi, okay? Let's do pi over 2 first. Okay, again, this is a long explanation for a very simple graph once we're all done with this. We're going to show you a real easy, short way of doing this, okay? So we said the sine at 0 is 0. We already did that. The sine at pi over 2 is 1. The sine at pi is 0. The sine at 3 pi over 2 is negative 1. The sine at 2 pi is 0. Okay? Now, let's deal with this one first. So, let's deal with 1. What's the reciprocal of 1? What's the reciprocal of negative 1? Negative 1. When you flip 1, you get the same thing. When you flip negative 1, you get the same thing. Okay? Please don't have died on me. Good, we're still going. Okay, so this point right here and this point right here are not only on the sine graph, they're also going to be on the cosecant graph. Okay? Now, at 0, what's the reciprocal of 0? It's undefined. It's not a number. So here cosecant's undefined. Here cosecant's undefined. Here cosecant is undefined. Okay? So, here, and I'm going to say this probably 3 times, 3 or 4 times. I'm going to say it real slowly. Even when I say it slowly, students have a hard time grasping this, okay? But it's all right here. Sine of theta is 0, and the reciprocal of 0, which is sine, I'm sorry, say that all over again. Sine of 0 is 0. We know that by looking at the unit circle, okay? The reciprocal of sine is cosecant, and the reciprocal of 0 is undefined. So cosecant is undefined, okay? Wherever sine is 0, cosecant is undefined because 0 has no reciprocal. There is no reciprocal of 0. Okay, you can't flip 0 because you'd have 0 on bottom. Okay, so how do I graph at 0 undefined? How do you graph undefined? You have what's called an asymptote. It's a boundary. Okay, did I ever teach you guys that word? And algebra 2 or not? Asymptote? No. A couple of years ago. Well, okay, you had a full year of algebra 2 though. They didn't. They got till March. Asymptote. That was one of my favorite words when I was in high school math classes. Okay, if you don't know why, then good for you. Okay, so it's a boundary. It gets very. Okay, did I use the example about walking across the room half the distance in algebra 2? Did I ever get to that last year or not? Think of it this way. Let's say this room is 40 feet. Let's say it's 40 feet. Let's say every day I walk half the distance. I didn't say I walk half the room and then half the room, I'm there in 2 days. That's not what I said. 40 feet. So the first day I walk 20 feet. I have 20 feet left. How many feet do I walk the second day? 10 feet. So I have 10 feet left. The next day I walk 5 feet. So I have 5 feet left. When do I get to the other side? Theoretically, never. Realistically, I'll be trillionths of an inch away. And you can't measure trillionths of an inch. You can't, okay? But that's what's a boundary. It's an asymptote. I never reach that wall. Okay, I get very, 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 very close to it, but I never actually reach it. Okay, so there's that vertical asymptote right here at 0. There's also going to be a vertical asymptote at pi. Wherever sine is 0, cosecant is undefined. We're also going to have an asymptote here at 2 pi. So do me a favor, on your little graphs here, draw a dotted vertical line through 0 and pi and 2 pi. Oh, do me one more favor. Where else do you think it's going to be undefined on the sine graph? Let's go to the left.
Negative.
Negative pi and negative 2 pi. Let's draw those in, okay? All right. Now, we're almost done today. if I did this, okay, if you guys are all doing that, just watch here for a second. And you gotta watch while I do it. Don't look away, you gotta be watching while I do it. Does this line have a positive or a negative slope?
Neither.
Is that line going up or is it going down? Oh, come on. You guys
I
realize.
mean, you drew it going up.
That's not what I asked. Does it have a positive or a negative slope? I know, I did it, I purposely did it the way I did it.
It should be negative because it's going, everything goes to the right.
Left to right, yeah. I tried to trick you a little bit because I drew it left to right, or right to left. Okay, you're supposed to read graphs left to right. So positive or negative slope? Negative. It's going down, right? It's going down from left to right. It's going up from right to left, but that's not the way you read graphs, okay? You read graphs from left to right, okay? Keep that in mind. You look at graphs from left to right. I get that. And you guys get that? We're all good with that now? Just like you read. You read left to right, you read graphs left to right, okay? So, even though we know that, okay, some of the time when I'm looking at this graph, I'm going to look at things left or right to left, and it's okay, all right? So what I want you to understand is this. One more time. What are these things in one word? Reciprocals, okay? They are reciprocals of each other, okay? So let's look at this sine graph. We're going to use the sine graph in order to come up with our cosecant graph, okay? We already know that this point is going to be on both graphs, okay? As I'm tracing this from left to right, it's going up. My sine values are getting what? Bigger or small? Bigger, and they're positive, okay? Bigger is good. I want you to say it a different way, though. If we're positive,
Farther from zero.
farther from zero. They're getting farther from zero, okay? So, they're getting farther from zero. So, if I was to go this way, I know you're not supposed to do it, but as I go right to left, they're getting what? Closer to zero. So, if I go this way, they're getting closer to zero. What would cosecant have to be doing? It'd have to be getting y, because they're what? Remember those numbers I just erased over here? As numbers gets bigger, the reciprocal, whatever happens to a number, its reciprocal does what? The opposite. So as I go from here to here, I know I'm going right to left. That's not the way you're supposed to do it, but it's okay. As I go from right to left, it's getting closer to zero. So cosecant's going to be getting farther from zero. So is it going to be going towards the axis?
No.
It's going to go away. When does it hit this asymptote? When do I get to that wall? Never. Never, 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 okay? Now let's look at this. Don't just watch. Don't write this down here, okay? As I go from here to here, what's happening to a sine graph? Closer to zero. So what's a cosecant graph going to do? It's going to go farther away from zero, okay? Let's look at over here. From here to here, as I go towards the asymptote, is it getting closer to zero or farther from zero? Closer to zero, because this is zero. These are negatives. It's getting closer to zero. So what's a cosecant graph going to do? Get farther from zero. As I go from here to here, what's happening to my sine graph? It's approaching zero, so cosecant's going to go away from zero. Okay? Go ahead and put those. So all you're doing is putting the dot right here. Don't have them cross that the asymptotes, though. I don't think I explicitly said this, but just think about what we've done so far in the last half hour. How do we graph a cosecant graph? What's the first thing that you probably have to do to graph a cosecant graph?
Put your,
Even before that. I didn't say it, but we did it. Before we graph a cosecant graph, you do a sine graph. You do a sine graph, and you use that to do a cosecant graph. What's the first thing we're going to do in order to do a secant graph? We've already done it. We're going to do a cosine graph. Yes, ma'am.
I just have a question.
Yes, ma'am.
Those thingies on top and on bottom that we just drew,
Uh-huh.
are those cosecant?
Those are the cosecant graphs. Yes, they are.
Okay.
Yep, those are the cosecant graphs.
Cosecant graphs kind of look like parabolas.
Kind of, but they're not. They're not exactly parabolas. Students say parabolas are U-shaped. Generally, yes, but that's not good enough, okay? There are U-shaped graphs that are not parabolas. Those are U-shaped, they're not parabolas. That's a very good point. Now, let's do the same thing here. Here we're at 1. What's reciprocal of 1? Itself. Have it go away. Have it go away. Now be careful here. Some students want to see if they guys get this or not. How many cycles of the cosecant graph did we just do? 2. Some people think it's 4. A cycle means you do it and then it repeats. So we have this. Bless you. Then we have this. Did that repeat it? Or not? No. Is this a repetition? Yeah, we did it back over here. above, below, above, below. That's 2 repetitions. Okay? That's 2 cycles of a cosecant graph. Okay? So, let's do our cosine graph, then we'll be done for today. Okay? We'll do the tangent ones tomorrow. All right? So, do you think, if you can get this, phenomenal. If not, it's not a huge deal. Listen carefully, though, because hopefully somebody will get this. Do you think there's going to be any asymptotes on a secant graph? Yes, there are. Where? At what radian measures is that going to have an asymptote? There's going to be 1, 2, 3, 4 of them. What radians? I need yours and pies. Why? You're right, why? Why is secant undefined at pi over 2? What's 0? Cosine 0. And what's the reciprocal of 0? Nothing. There's nothing. Okay? So we're going to have 1 at pi over 2. Jesus, marker's about dead. Where else? 3 pi over 2. And at negative pi over 2. And at positive, or negative 3 pi over 2. Okay? Let's do this one right here. Let's look right here, smack dab in the middle, okay? So, right here, as I go from left to right, what's happening to the cosine graph? It's approaching 0. So, the secant graph's going to do what? You said get larger. There's a better way of saying that. Farther from 0. So, it's going to go like this. What's happening here? It's approaching 0, so secant's going to go away from 0. Here, they're going to go away. Wherever the cosine is, they're going away from it. They're going away from the cosine graph. Okay. Now be careful here. I see this every year, and I hate to say this, but I'm going to mark people wrong if they do that, okay? Here's what I'll see people do. One more time. When do I get to that wall? Never. Theoretically, never. Realistically, I do, but theoretically, I never do, okay? So, here's what I see students do, okay? Don't do this. If you're working ahead, I'd stop for just a second. It's going to take just a couple seconds. This is approaching 0. So, secant's going to go away from 0. And here's what I see students do. Okay? Is that going away from 0? Yeah, it is. What's wrong with it, though? It's going to what? It's going to hit the asymptote and cross over. So, here's what you do. It shouldn't go like that. I should go like this. Because otherwise it's going to hit the asymptote. It never touches the asymptote, okay? Same thing here. This is going to go down like this. And again, this is going towards 0, so it's got to go away. So, how am I going to do it? Is it going to go like this? What's wrong with that? It's going to cross the asymptote. It has to go like this. Okay? And what you need to understand is this. This is not just going up. It's approaching the asymptote. It's getting very, 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 very close, but it never actually touches it. Okay? All right, so what I want you to understand is this. Here's what I want you to be able to do. I will just watch for a second here. There's a lot of stuff here, but and what you're going to find is after tomorrow, you're going to find the first couple days after this, it's really easy stuff. Then it gets a little tougher. Then it gets really tough. Okay? If I ask you on a test, y equals sine of theta. Let's do this. Y equals cosecant of theta. How are you going to graph a cosecant graph?
You have to make it fine.
You make a sine graph first, okay? And how I want you to make a sine graph is you're going to go 2 pi, pi, pi over 2, 3 pi over 2, 1, and negative 1. Sine graph starts in the middle. Middle it's halfway there, 2 pi it's there, pi over 2 is here, 3 pi over 2 is here. Go like this. There's our sine graph, okay? Then, how do I make my cosecant graph? I put my asymptotes at where, and where? 0, pi, and 2 pi. Goes away, goes away. Okay?
That's all you want us to do for this.
That's all I want you to do. Now, these are just the generic graphs. We're going to start sliding them around and stretching them and crunching them and flipping them and all kinds of stuff to them, okay? But you have the general idea what the graphs look like,
Yeah.
okay? So that's it for today.
It looks like a lot. It's really not.
Yeah.